waking up. All right. Harder primitives. Okay. So I think the important thing here, as you can see, the little keyword we wrote, hence. Always use hence when provided. So if it says hence, it actually means you've got to use the one before. So let's have a look at how these ones are completed. Now, most questions you'll see in your exams are what we say just structured questions. The reason why they're structured, they're going to give you a part A, they're going to give you a part B. The unstructured ones, they're going to ignore A. You've just got to know that you have to do part A for yourself, and then you've got to do part B. So the unstructured versions would just be, here's the question, just find the primitive of this. And there's no way you're going to do it without having to do A first. All right. I know some of you had done this at school last term, and the way I teach this, and compared to obviously your textbooks, is a little bit different, only because this particular concept is actually in the 4-unit course. Because it's in the 4-unit course, I have to teach it the easiest way that's possible. Whereas from your textbooks and maybe your teachers who haven't taught 4-unit, they'll do it a little bit harder. So this method's going to be a little bit different, but I think you guys will actually understand this pretty well from the way I'm about to say it. So let's see. Part A says differentiate x squared plus 1 to the power 4. How do I differentiate x squared plus 1 to the power 4?
Bring the 4 down, minus the power from the top by 1, and then times the outside by the derivative of the inside of the brackets. Great
work. 4 times 2x is 8x. X squared plus 1 cubed. Thank you. Part B. Part B says, hence find the primitive of 8x, x squared plus 1 cubed. Well, what do we know about this and the relationship to this? So what do we know about, let's call it the yellow highlighted section to the blue highlighted section? What needs to happen? How are they related? How are those two things related?
Yellow is the primitive of the blue one.
Yellow is the primitive of the blue one, and the blue one is the, I think you said it wrong. It would be the yellow one is the derivative of the blue one, and the blue one is the primitive of the yellow one.
Yeah, that makes, yeah.
Yeah. So one more time. The 8x, x squared plus 1 cubed is the derivative of x squared plus 1, which is exactly what we just did. We found out that the yellow bit is the derivative of this. In other words, you could say x squared plus 1 to the power 4 is the primitive, or I like just to use the word integral, is the integral of 8x, x squared plus 1 cubed. So therefore, if I came up to you and I said B, hence find the primitive of this. So how do I integrate this? The answer straight away is x squared plus 1 to the power of 4 plus C. Any questions? You sure? Does everyone get that? Okay. Can somebody tell me why, if this was just the question, just to forget everything else now, right? If this was just the question, why would I be stuck? Can somebody tell me, from what we learned yesterday, why would I be stuck with a question like this to be able to integrate it? I had nothing else. Come on, you guys got to realize the problem. Why would I be stuck in a case like this? Look at it. Tell yourself, okay, how do I integrate this? What are two big problems?
It's not linear, so you can't use a rule, and the 8x at the front.
And what's the problem with the 8x being at the front?
You can't factorize it out in any way.
Yeah, and pretty much you're right. I'm just going to agree with that. That's fine. There is no product rule for integration, right? So when you have an x multiplied by another x, that's bad. There is no product rule. It doesn't exist, right? We haven't spoken about anything like that. So you automatically, if you've got two variables that are multiplied, that's a fail. It just won't work. And then if it's linear, if it's not linear inside, you also can't use the chain rule. And that's how you'll realize when it's unstructured. So right, like I said, right now we're doing structured. When it's unstructured, what you're meant to do. That's how you're meant to look at it. That's good. All right, we'll do another one. Anyone, again, one last time, have any questions about that? All right, let's try example 17. Part A, anyone want to try it out to see if they're understanding how to do A and B? It'll be a good one to try. Y equals x squared, take away 5 to the 6. Stefan, let's do it together, this one. Stefan, you ready? Stefan, no? All right, where can we go for then? Emily.
Okay.
Let's do it.
So the first step you would do was you recreate it. So I got 12x bracket x squared minus 5 to the power of 5.
Yeah, you've already finished it all off. 6, bring it down, x squared take away 5, power of 5, and then times by 2x, which becomes 12x. Beautiful. Okay, now, part B. Hence, find the primitive of this. So what's the biggest difference from what we have here compared to what the question's asking this time?
It doesn't look the same as
It looks like it's all the same except what?
the 12 in front.
12, right? Okay. So when you get a case like that, you still do very similarly to what we just did above. What would the integral, so don't forget the question, right? You don't look at this so much. So ignore that for a second. Think of this. What would the integral of 12x, x squared minus 5 to the power of 5 dx equal to? What would the integral of this be?
Would it be the x squared
Yeah.
minus 5?
Right? But that wasn't the question. The question was now find x squared minus 5 to the power of 5. So what number don't you like here?
You don't like the 12.
Right? But didn't we say yesterday that we can take constants out?
Yeah.
So we're going to get rid of this 12, put it on the outside, and then what are you going to do with this 12 here?
You just
So yeah, divide it. Plus C. That makes sense?
yeah.
Everybody else? So you see how I didn't actually follow the question, and I think that's again something you guys got to get used to. Even though it says hence find the primitive of this, that's not the technique we actually approach. Your teachers might, that's how they might do it, but we don't do it like that. We think of it as if I just differentiated something, I now know the integral of that is the opposite. It's the one on top. So you start off with that, then you try to get from here to here. And it's very easy to realize, oh yeah, I've got an extra 12. Just divide it over. All right. No more questions? Okay. Stefan, you think you're ready for the next one? Or not yet? No? All right. Rad, let's do this one then. Brad, you there? Novak? Come
Yeah,
on.
I'm here.
Let's do it, buddy. Example 18. A. Differentiate x cubed plus 5 to the power of 4 with the full setting out of the chain rule. Easy. So let's do
Okay.
differentiate it. Y equals,
4
sorry, y dash equals 4.
y dash.
Yep.
Brackets x cubed plus 5 to the power of 3 times 3x squared.
Which becomes 12x squared, x cubed plus 5, all cubed. Question says, hence find the primitive of 12x squared. Well, what would part B be? What would be the primitive or the integral of 12x squared? X cubed plus 5 cubed.
It's the same thing.
So tell me the answer.
X cubed plus 5 to the power of 4.
That's good. Yep. And then part C. Hence find the primitive of this, which looks very similar to this, except
Which is a
again.
12.
So therefore the answer
Take
to
the
x
12
squared.
out.
Take the 12 out. So you want to just say the answer again?
Yeah, so it's x squared, x cubed plus 5 to the power of 3 over 12.
No. X cubed plus 5 to the power of 4 over 12. It's this one.
Oh, okay.
That's the question. X squared, x cubed plus 5 power of 3. That was the question. You're trying to find the integral of this.
Oh, so it goes a power up. Yeah. Yeah.
But no, you're not increasing it by power up. Don't say you're powering up. It's because the derivative of this is this. That means the integral of this goes back to up here. It's just like you saying expanding and factorizing. If I expanded this, it gives me this. If I factorize this, it gives me this. Expand, factorize. Same thing. Differentiate, integrate. Differentiate, integrate. So I'm not actually increasing it by 1. We're not actually integrating, if you're realizing this. Are we integrating?
No,
Did I
we're
actually
not.
integrate here? You can't. Why
No.
can't you integrate here? That's a product rule and that's nonlinear. We're not actually
Yeah.
integrating. We're just using the logic of opposites. So
Oh,
be
okay.
careful.
I see. Yeah.
Yeah?
Yep. Yep.
You can't integrate this. Okay. And we go again. Example 19. Let's try this one. Let's try this one. D on dx of this. That just means differentiate. It's just done in a different way. So if you ever say D, you know how usually you say dy on dx, which means differentiate your y.
Yeah.
But if I don't want to write the y, I can write d of 5x because y is 5x. And that just means differentiate. So whenever you say d on dx, just means differentiate. All right. So let's do part A.
So bring down, so 4 on 3 bracket 5.
Let me just write it like this for a second. Give me a second. That's the original, just so we're all on the same page. Y dash equals, yep, 4 on 3.
Yeah, bracket 5 minus 3x to the power of a third.
Third times by negative 3. Okay, simplify that now. 4 on 3 times by negative 3 is negative 4.
Yeah.
And then 5 take away 3x to the power of a third. You happy with that?
Yeah, that's right.
Hence or otherwise, but like we said, usually try to do the hence, because that just means use the one above. So use the result above. Evaluate this. Okay, well, again, don't start with the question. Don't do that. That's wrong strategy, right?
Mm-hmm.
What we do is we write part B, because you already know what's going to happen. Part A is going to be like differentiate. Part B is going to be integrate. But you don't look at what you're trying to integrate. What you do is, you know, in part B, the integral of negative 4, 5 take away 3x to the power of a third, dx becomes what? What does the integral of this become?
5 minus
Yeah.
2
To the power of?
4/3.
Right. You know, specifically the integral of this will go back to the original case again.
Yeah.
Now you stop and you go, okay, what do I need? I needed just the third, just this bit here.
Yeah.
I don't need this -4. So what are you going to do with the -4?
Take it out.
And what? Take it
Divide.
out, divide it. And that's the answer. So therefore the answer that you're looking for, which is cube root of 5 take away 3x dx equals 5 take away 3x 4/3 on -4 plus c. Easy?
Yeah.
Easy. So no integration is required here. I think that's what I'm trying to make sure you guys understand.
I'm confused why it just, like the third on the left, does that not matter? Like, does that not matter?
Wait, 1/3? Yeah, of course it does. 1/3 is a cube root, isn't it?
So you just have to make them equal each other? Is that what we're trying to do?
Wait. Let's take it back a step. Are you worried about this 1/3 and then changing it to a third? Is that the
No, that's fine. It's just, how does it? I'm confused. Like the steps, the math.
black? Are you confused about the black compared to this maroon color?
No, like the
no?
black with the black on the other side. Like, are we trying to?
Right. Okay. Yes. So what I'm trying to say, the best way to write these is if I knew, how can I say this? If I knew, okay, 3x plus 6, that equals to 3x plus 2, right? Factorized.
Yeah.
If for some reason I wrote 3x plus 2 on this line down here, I also can say that equals to the expanded version, which must be 3x plus 6.
Oh, okay.
That's technically what I'm doing. So I'm saying here's the original. So here's your f of x. Here's your derivative, which is your little f of x.
Yeah.
Now we know the integral of the f of x. We know the integral of the little f of x must give me back to the original capital F of x.
Yeah, that makes sense. Yeah, that makes sense.
That's all I'm writing. And the reason why I'm writing it like that and not starting with the original question is because I'm trying to show you guys the original question will already have some things missing. Like there's no -4 there and whatever. And that's usually a lot harder to find and identify than if you do it the way I'm showing it, which is, well, if I know the derivative of a function, then I also know that the integral of that function is back to the original again.
Yeah.
And so on. So we start like that. Hold on one sec, you guys. All right. All right. Good. Any other questions? No? All right. That's good. That's good. Look at it now, unstructured. So for this case, I haven't given you part A, and these ones are really hard. So these are probably the hardest questions you'll see in your integration exams. The reason why these are really hard is because I haven't told you exactly how to start this. There is no part A or part B or anything like that. It just says find the integral. And for students who are to start this without knowing, hold on, I can't do this because that's a product rule. Hold on, I can't do this because it's linear. They wouldn't know exactly how to do this. They'll probably just integrate these individually and it'll all be wrong. The way it's got to be done is exactly the way we just did it up here. All right. So you've got to actually find the derivative. Now, what was the, if you look at, let's say, if you look at the question, let's go with a more basic one. Actually, let's look at all of them. All right, look at this question. What's actually the same in both? Look at this question. Again, what's the same in both? All right, one more time. Look at this question. What's the same in all three? Starting to realize what I'm trying to get to? What's the same? So, what must the answer at least be? Can somebody tell me?
X cubed plus 1.
Yeah, right. At least I think we can all agree. Does anyone not agree with what I was trying to show there? We have seen a common theme that the insides are always there. X cubed plus 5, x cubed plus 5. X squared minus 5, x squared minus 5. X squared plus 1, x squared plus 1. Okay. So if we all agree with that, then we at least can know, after knowing that, I can't integrate because, product rule and not linear. So I can't actually integrate. So once you've established that, you're like, okay, I remember when we did this, it was pretty much the x cubed plus 1 existed exactly the same. So there's your x cubed plus 1, x cubed plus 1. Now, if you're integrating this time, if you were to integrate, what do you think that power should be? Is it going to be a 3, a 4, or a 5?
5.
Why?
Because you're going up, you're integrating.
Going up. Good. So we can at least agree now. We have it up to this stage. Yes? Have I lost anyone again? Because now what I'm about to do is what your teachers will do very differently. But you're okay for up to this stage? All right. Now you pause. So stop and differentiate. What? Yeah, differentiate. Exactly like we did up here. We were differentiating, weren't we? All of these questions, it's all about derivatives. So you got to do the same thing. So once you've established your answer almost, you've got to stop and differentiate. So let's differentiate this guy. Can someone tell me the derivative of this brown bit, please?
15x squared bracket x cubed plus 1 to the power of 4.
How close are you to the original question? What's the only difference? That 15, right? So what are you going to do, Maria, to that 15?
Do you divide it?
You're going to divide it by 15 plus C. Why did you say divide?
Because it's times 10.
It's multiplied by the 15. It doesn't have a 15 here. We're going to divide it out. And that would be the answer to the question that we're looking for. So that's super weird. I told you guys it came from 4 unit. So it's meant to be a little bit confusing at first, but we're going to do a fair few and hopefully we can wrap our head around this. So the trick is we at least know the bracket's the same. We know we're going to increase the power. You do that, you stop, you differentiate, you look at what your derivative is. If it's not exactly the answer, that means this answer is not correct. That means you've got to do a little bit more. And we saw that the extra 15 we didn't want there. We've divided it out and now we've got the answer. So now if I differentiate this, obviously we know it's going to be exactly this orange bit divided by 15. 15 to cancel and see, you're back to the original question. But let me not confuse you more right now. Let's have a look at a few more and then I think you guys will get the hang of it. This one here. Let me just rewrite it without the surd. All right, x 1 minus 4x squared to the power of a half. Aya, do you want to give it a shot? Tell me. The first thing I'm going to write here, bracket.
1 minus 4x squared to the power of a half.
No. You got to increase it by 1.
Negative half.
No, increase it by 1. Because you're actually integrating.
Oh, so we don't differentiate this.
No, not yet. No, wait, hold on. You first integrate it like that. So you add 1 to the power. So
And-
half plus 1. We don't divide by the power. It's not like that. It's not like what we saw yesterday, unfortunately, because there's a lot of moving parts for these styles of questions. So we're just going to add 1 to the power. Then at this step, at this stage, you stop and differentiate. The reason why we're differentiating, because what should happen if this is the answer, so if this is the actual answer to this question, what should happen to the derivative of this orange bit? It should just give you back to the original question.
Mm-hmm.
Isn't that what should happen if it's right? So that's what I'm saying. Stop and differentiate. So we're going to double check, see if it's right. If it's not right, we adjust. So let's differentiate the orange bit. So 3 over 2, 1 minus 4x squared, half times negative 8x. Yep.
Yeah.
What now? What's negative 8 times 3 over 2, 24, 12? Negative 12x, 1 minus 4x squared, and then power of a half, which is just a third. You're okay with that?
Yeah.
Now, again, compare this to what it should have been.
We have extra negative 12.
So does that mean is your orange part, that just the orange part that I've written just now, was it correct?
To the...
Well, was it, is this orange bit correct to just this brown bit? No, because the orange bit, when you differentiate it, you still got an extra negative 12.
Mm.
So the orange bit's not complete. Now you go in. So after this step, you go in and you write it over negative 12.
Wait,
And
Sam,
that's
I've got
the
a
answer.
question.
Plus C. Yes.
When we differentiate, are we supposed to differentiate the orange or the...
Correct. Yeah, no, you don't
Okay.
touch the integral. Well, because look, again, the integral of this, the integral of this is this. What does that mean about the orange? The derivative of this is this. That's why I'm differentiating the orange, to double check, is my answer correct? It's like, again, back in year 9 when you would have learnt expansions and factorizing, we would have said, or solving equations. Hey, when you've got an answer, double check it. That's literally what you're doing. Here's my answer in orange, and I'm stopping, I'm differentiating to double check it. I realize it's not right because there's a negative 12 there. The original question does not have negative 12. Easy fix, divide by negative 12. Who is actually lost? Because that's the person that should do it next. Believe me. This is not one concept you wanna leave. You saw yesterday's one, they were okay. This is one concept because it's been brought down from high levels of math. It's tricky. Your teachers will do it very differently, but believe me, this is the most efficient way to get it done. Who wants to give it a go next? Please, somebody that doesn't feel confident, they should do it. I'll work it with you. Come on. Who's it going to be? Come on. Nikki, shall we do it?
Okay.
Yeah, please. You want to. You don't want to hide away from it. Have you written everything down, firstly?
Yeah.
All right, let's go. Again, no quotient rule. You don't want the 3 to be at the bottom either. Oh, missed the dx there. You don't want the 3 to be at the bottom. So let's rewrite this out to the way we would usually see it, which more looks like that. Do you agree?
Yeah.
Okay. Can you tell me what my next line would be in orange? 5.
X squared minus 1.
To the power of?
Negative 3.
No. You're going to add 1 to that power.
Oh, okay. So -4.
-2.
Negative.
Yeah, you subtracted 1. And that's it. You leave it at that. You stop there. All right?
Yeah.
And then we stop and differentiate.
Yeah.
This orange bit. So what's the derivative of this now?
-2. 5x squared. -1. -1. Or do you?
-3 now because you're differentiating.
Yeah. Okay.
As you want it to be. You want it to be -3 because the original question had -3.
Yeah.
All right, go back. So -3 times
10x.
Perfect. Again, very close. So look what you've got. You've got now -20x, 5x squared minus 1 to the power of -3. You only wanted x 5x squared minus 3. You only wanted this bit. So what are you going to do with the -20?
Divide it.
Divide it over. Plus c. And that's the answer we're looking for. Think you're getting the hang of it?
Yeah.
All right. Who wants to give it, the next one a shot? Come on, I'd rather some of you guys pick it, like, you pick yourself instead of me picking on you. Who wants to give the next one a shot? No. All right. Rad, can you do it now? Or Stefan? I'd like one of you guys to try. Rad, Stefan, come on. No. All right then. Who's next? Lysandra, you said that. Anouk, it's your question. Example 23.
All right. So I differentiate bracket.
No, you're not differentiating. You're writing the bracket first.
Yeah, I was going to differentiate what was in the bracket.
No. Incorrect. So what you do is you first write the bracket with 1 higher power.
Yeah, that was what I was going to get to.
Oh, okay, fair enough. Yeah, it has to be 1 higher power because when you differentiate this, you want a power of 2. All right, all good. Sorry. Go ahead then. Stop.
I'd write the third as a power as well. I think that might make it easier.
Yep, that's fine. You tell me.
Yeah, so the derivative would be 3 bracket root x plus b bracket half x to the minus half, right?
This bit's
Plus
correct.
1. Or was
But-
it plus b?
No, this bit's correct because x to the half, when you differentiate that, you bring the half down, x negative half. I agree with that. I don't have a problem with this. But there should be a power here that you're missing.
Oh, 2.
Yes. So again, you're pretty close. There's your root x plus b squared. So all of that's the same. X to the negative half. Well, isn't that the same as just going root x at the bottom?
Yep.
So what you've got right now is you've got 3 bracket root x plus b squared on 2 root x. You're pretty close. You've got an extra 3/2, which you don't need.
Okay.
So what do you do with this one now? You times it by?
3/2?
No, 2/3.
2/3.
You're doing the opposite, right? You want to get rid of the 2, divide, so you multiply. It's multiplied by 3, you divide it by 3.
Right.
True?
Yeah.
You're getting rid of the 3 over 2. Your 3 in the numerator goes in the denominator. Your 2 in the denominator would go in the numerator. And then plus c.
Yeah.
All right. Let's find the primitives for those. Again, how do you realize when to do those ones? You can see, like, again, the quotient rule style ones, but then it's non-linear as well. You can't split the fractions up. You see that? You can't split the fractions. So let's have a look and see if I've got a few here. Not many. But let's just do question 14. All right. Three x plus 1 . All right, Aiden, let's do it. Question 14A.
Yeah. So I'd rewrite it as 4x bracket 2x plus 1 bracket to the power of half.
Yep, and you're differentiating this time, so what must you use?
And then I'd write it as half.
Just before you start, what must you use when you're differentiating something that looks like this?
What do you mean? Sorry?
There's two x's that are multiplied and you're differentiating. What particular rule do you have to use?
Is it that S symbol?
No, you're differentiating. Think of derivatives, think of your rules for derivatives. What were the rules? There was 3 rules. They had names. One started with a P, one started with a Q.
Oh, chain rule.
One started with a C. You'll have to use your chain rule for this, yes. But when there's 2 x's, what must you use? You're missing it.
The product rule.
You have to use the product rule to actually be able to differentiate this.
Yeah.
So careful. That's your U, that's your V. What's your Y dash?
It would be 4x.
No. Oh, do you do V dash first?
I was doing U first times dash.
Yeah, U times V dash. Is that what you're doing?
Yeah.
Okay.
So
So that becomes 4x times?
times 2.
How do I differentiate V? V is this whole thing. Half 2x plus 1 negative half times 2.
Yeah.
Plus, what's U dash?
4.
4 times V.
Yeah. Bracket 2x plus 1 bracket power of half.
2 and the half cancels out. You're left with 4x and then 2x plus 1 to the negative half plus 4. 2x plus 1 to the power of a half. And just because we can see what part B looks like, can you see it's a common denominator with part B? So I know I'm not going to leave it like this. I'm going to do a bit more math. So let's keep going. 4x on. Negative half becomes 2x plus 1 in the bottom plus 4 on 2x plus, nope, not on. 4 times 2x plus 1. Oh, let's leave it as a third so it looks a little bit neater. There we go. Now, I want to make that into a common denominator. So what's my next line going to be?
It would be
All over what, at least?
2x plus 1.
In square root.
2x plus 1.
Yeah. And then that's the same. So then the top's just 4x.
Yeah.
Plus, you're missing the third here. So you're going to multiply the third by third. What happens when you multiply third by the same third?
The third cancels out.
The third cancels and you end up with that. We're almost there. 4x plus 8x is 12x plus 4. There we go. Something that looks similar to what we have in part B. At least the thirds in the bottom. Okay. That was just differentiating. Had nothing to do with the actual integral. So be careful with that. You might need to review a bit of differentiation there. Part B. What do I know about the integral of 12x plus 4 on square root 2x plus 1 dx? What does the integral of this become? All the way back to the original, right?
Yeah.
So that I know that becomes 4x 2x plus 1 to the power of a half plus c. You agree with that?
Yeah.
The question didn't ask for 12x plus 4. What did it ask for? 3x plus 1. So what are you going to divide out to make it into a 3x plus 1?
You can take out the common number,
which
is 4.
4. That's exactly right. So you're actually going to divide the left side by 4. If I divide this by 4 and divide this by 4, that means technically this becomes the integral of 3x plus 1 on, which equals 4 divided by 4 cancels out. I'm left with just x, 2x plus 1 to the power of a half plus c.
Yeah.
Happy with that? All right. Tricky. Anybody have any questions? I'll let you guys copy it down for a little bit. Let me know if you have any questions. All right.
Sam,
Yes.
could you go through B again, please?
Yes, of course. Before I do that, do you understand the idea of the whole, well, I guess what's happening with the antiderivative, which is the integrals, and then the derivative itself and how they're related? Yeah, that it's making sense like that?
Yeah, please.
Okay. All right. Just put this over here. All right. So, where are we? So, if we just worked out for part A that the derivative of the orange gives me this answer here. What does that mean about this answer here, this black answer with respect to the orange? Well, I know that the integral of this black component must give me the orange component. Is that correct? Is that correct logic there?
Yep.
That the integral of this gives me the orange. But the question did not have 12x plus 4. It had 3x plus 1. So the difference between 12x plus 4 and 3x plus 1 is that common factor of 4. So if I factorize a 4 out, I'm left with 3x plus 1.
Okay, right.
And that's why I don't want that 4, so I'm dividing it out, and then, yeah. Can you see that better now?
Yep.
So really, I guess I could have done an extra line here, and we could have done it like this. Integral 4 3x plus 1 on square root 2x plus 1 dx equals still 4x 2x plus 1 to the power of a half plus c. And at this stage, I know that I don't want the 4, so I'll divide it out, And you get the same answer I've got in the black up there. All right, good. Anybody else have any questions? All right. The hardest skill to probably learn is that one there. I think in all of the all of the integration topic. So don't neglect it. Just do the exact questions I've given you 2-3 more times, and you'll get the hang of it. The structured ones are usually okay. They don't have a big issue with them. It's more the unstructured ones where you have to stop, differentiate, go back, fix up, and so on. Those are a little bit more annoying. Okay. All right. Now we're done for time 10:50. If f dash. All right. Now these should make a lot more sense as well. So let's look at these. So in the derivative topic, we were asked to find tangents, right? So what we had to do, we had to differentiate. We had to differentiate, sub in the point, work out the gradient. From that, used y minus y1, and eventually find the equation of my tangent or equations of normals. This time, what's gonna happen is we're going to be given the gradient function. So you're already given y dash. We actually want to find the original question. So we're going back up. We're trying to actually integrate to find the original question. Let's see how these work. All right, let's start with 7a. Well, actually, I won't start with that. I know I had a question there to do first. So we go back up. This one here. This is from 1996 tuna HSC question 5. The graph of y equals f of x passes through the point 1 and 3. So we've got any graph. We don't know what kind of graph it is. We don't know what kind of graph it is, but we know that it specifically passes through the point 1 and 3. But we know the derivative. We know f dash of x is 3x squared take away 2. So we know f dash is f of x. All right. Anybody have any idea? If I know the derivative, how am I going to find the original? What would the technique be? If I have the derivative, I need to find the original again. Pretty much what we have been doing yesterday and today. What's the topic called?
Integration.
Integration. So how do I go from the derivative into the original again?
Integrate.
Integrate. So to find f of x, we're going to integrate 3x squared minus 2. Novak, what's the integral of 3x squared? Now you actually just follow your normal integration rules.
So 3x cubed on 3 minus 2x plus c.
3 and 3 cancels out. Now you know it's roughly x cubed take away 2x plus c. That's what f of x is. But again, it specifically told you it goes through a point. What letters are these? What letter is this and what letter is this?
X and y.
X and y. So you're going to sub x is 1 and y is 3. What letter will you solve for?
C.
C. You actually can find C. 1 take away 2 is negative 1. C is equal to 4. Therefore, f of x equals x cubed minus 2x plus 4. That's not too hard, right? Again, you just got to understand that the logic of, if I've given you the derivative, let's find the integral. Well, that just means, find the original. That means you're going to integrate. You're going to have a plus c, but this time if I gave you the point, you're going to sub in that point, you'll find your constant, and you're able to find the original function. Why am I allowed to integrate this, Novak? Why am I not doing all that weird stuff I was just doing at the beginning of this lesson?
Because it's linear.
No, it's not.
No, it's not linear. It's x squared. My bad. Because there's no like rules involved.
Yeah, there's no product rule. There's no quotient rule. There's no chain rule. There's nothing. It's just individual terms.
Yeah.
So it's allowed. There's no problems there. Look, again, compare that to what we're looking at. Look at that. Look at that. Integrate that. Whoa. Integrate that. It's starting to look weird. So you guys got to understand why we were doing certain things at certain times. Okay. All good. Any questions about this one? And then we're going to do a few more of those. All right. Then let's start from the top. Aiden, you're going to go first. Let's do question 7a. It says again, if f dash 7a, f dash is 3x squared and f of 1 is equal to -2. Find f of x. How do you find f of x? Using what method or what technique? If you're given the derivative and you want to find the original,
You integrate.
you're going to integrate. So f of x equals what? The integral of 3x squared, which is what?
It will be 3x to the power 3 on 3.
Yep, which just becomes x cubed, right? Plus c. And what does this mean? F of 1 is equal to -2. What letter is this and what letter is this?
The one is x, yeah, and then the -2, yeah.
You're overthinking it, but look. If I gave you f of x is equal to, let's say, I don't know, x squared minus 1.
Yeah.
Right? If x is 1, that means f of 1. Doesn't that mean the y value is 1 take away 1, which is 0? So when x is 1, the y value is 0?
Yeah.
Yeah, that's pretty much what you're doing. Oops.
All right.
All right, get rid of that. Okay. So, you know x is 1, y is -2. So come down here. You now know f of x is equal to x cubed plus c. X is 1, y is -2. What are you going to do?
So would it be -2 equals bracket 1 to the power 3 plus c?
Yep, correct. And then take away 1, so -3 equals c. Therefore, what does f of x equal to?
-3.
No, f of x equals to x cubed.
Okay.
And then plus c, which is -3.
All right.
Careful. Yeah?
Yeah.
Isn't this actually easier than finding equations of tangents and normals?
Yeah.
I don't know, I find these easier because there's no y minus y1. There's nothing like that. It's just simply, you just integrate, sub in the point to find your constant, and then rewrite the equation out. All right, B, Anouk. Y dash equals 4x minus 1 and y equals 7 when x equals -1. Find y as a function of x, which is always the case, right? You're always going to find y as a function of x. So y dash is 4x take away 1. Let's write it down here. Y dash equals 4x take away 1 and y equals 7, x equals -1. Y equals 7, x equals -1. All right, go ahead and tell me what to do.
So first we
First we integrate.
Yeah, so we get 4x squared over 2 minus x, which is just 2x squared minus x plus c.
Plus c. Don't forget your plus c. So we're going to integrate it. We get something like this. Do you need me to write the integral sign for this, or you're okay with me just skipping it?
Oh, that's fine.
That's fine. Yep.
And then we sub in y equals 7 and x equals -1. And we
Yep.
find
So
c.
that's when you do need to use brackets like Aiden used above, because you don't want to get it wrong. There you go, and there you go. So that's 2 plus 1 is 3. 7 take away 3 gives you 4. And therefore?
Y equals 2x squared minus x plus 4.
Very easy. Easiest 2 marks you're going to get in your papers for that. All right. Part C. Who's going to do it? Aya, your turn. C is y dash equals -3. F of 4 is 7. Okay. Y dash equals -3. F of 4 equals 7. All right. Again, y is equal to the integral of -3 dx. What should the answer be?
Just -3x.
-3x plus
C.
If you don't say plus c, you're not going to get into the habit of it. You got to keep saying it plus c. Good. X is
4.
Y is 7. So therefore 7 equals -12 plus c. C is equal to 19. Therefore y equals
-3x plus 19.
very easy. All right. Oops, sorry. Questions from anybody? All right, Joey, you're going to do this last one then. If you get it out, then I think we'll move on. D. You're going to do D, Joey. Hold on. Y dash is 12 3x squared. All right, hold on. D. Y dash equals 12 3x minus 2 cubed. And the graph of y because passes through 1 and 2, find, okay, so we know 1, 2, 1, 2. All right. 1, 2. All right, Joey, you ready? Joey. No, come on. Lissandro. No, Mike's not working, you said. Rad, Stefan, what about you two? Any of you there? All right. You guys got to fix it. Mariette, let's finish it off. Y dash equals 12, 3x minus 2 cubed. All right. Before we start, is this a product rule?
No.
So we're so far happy. So
no,
far happy.
It's not.
So far happy. Is this linear?
Yep.
Yay. So we can actually do this just normally. Yeah?
Yeah.
So here we go. Let's integrate 12. Do you want it inside or outside?
I put it on the outside.
I agree. I like it. It's just a bit easier to see, so it doesn't bother you. 3 dx. All right. Y equals 12. Tell me, what's your answer for this one? Integrate. So 3x minus 2 to the power of?
4.
4 over?
Over 4 times 3, so 12.
Yeah, correct. And then plus c. 4 times 3 is 12. 12 and 12 cancels out. Then what do you do now?
You sub in the points 1 and 2 to find c.
You don't want to have a plus c. If you've got to find f of x, right, or y values, did they ever have plus c's before, like in year 11 and so on? We never had plus c. So they're usually going to give you a point. You've got to find your constant. And then once you find your constant, you can have your original question. So sub it in. Y is 2. 3 times 1, take away 2 to the power of 4 plus c. 3 take away 2 is 1. 2 take away 1, c is equal to 1. And therefore, y equals plus 1. All good? All right. Very good. Very good. I think that's all that done. That's really good. All right. 11:06. Let me think. Firstly,